This video is going to go over the 4 examples that are in your notes page. The directions are to simplify to a single trig function or value. So in number 1, notice that we have multiple terms going on. Our goal is to get down to a single one. So we're going to start with looking at that notes page and know that our goal is to use one of the 3 Pythagorean identities. So let's see what we can find. I have a sine, but there's no squared, so that doesn't help me with my formulas. But I do have a cotangent squared. So I'm going to see if there's any formulas with a 1 and a cotangent in it. If I look over at my formulas, noticing in number 2, a 1 plus cotangent equals cosecant, and noticing that they are squared. So I have a 1 plus cotangent. I can now get rid of that 1 plus cotangent and instead substitute cosecant squared because it's the same thing. So now my 1 plus cotangent squared is gone. It has been replaced with cosecant squared, and it's still being multiplied by sine. Let's simplify further. So I've got a sine here and a cosecant. I know that this means sine times, and cosecant is 1 over sine squared. Again, if it's squared, make sure to keep it squared. And squared means there are 2 of them. So there are 2 signs on the bottom of the fraction. So I'm going to expand it further. I have 1 sign on the top, and I have 2 signs on the bottom. That allows me to reduce. I can simplify one of the signs from the top and the bottom. And now all that's left over is 1 over sine. 1 over sine x. And again, if you can't remember what 1 over sine x is, that's okay. Double check your notes. 1 over sine is cosecant x. Our goal was to simplify to a single trig function. I'm looking down here, and I am down to a simple trig function, meaning just the one, and it is cosecant. So I started up here, and I continued to simplify until I got to 1 trig function. Moving on to example 2. So in example 2, I'm noticing I have a 1 minus sine squared, and I have a 1 plus tangent squared. I'm going to see if there's any of these in my Pythagorean formulas. A 1 and a sine squared is the first one, but it looks a little different. So we're going to take a pause and move on to the other one. 1 plus tangent squared. If I look at formula 3, tangent squared plus 1 is the same thing as 1 plus tangent squared. That means I can take out the 1 plus tangent squared and instead replace it with secant squared. A reminder to make sure to include that squared. Now let's take a deeper dive into the 1 minus sign. So the original formula for number 1 is sine squared plus cosine squared is equal to 1. But they have a 1 minus sign. So let's take that sign and move it to the other side. Sine minus sine, this gives me cosine squared is equal to 1 minus sine squared. All right, so I was able to use the first formula, move some stuff around to make it look the same. 1 minus sine squared can be replaced with cosine squared. So I'm going to cross out this one and replace it with just cosine squared x. Now these two things are being multiplied together. That's what those parentheses mean. So let's break this down. Cosine squared means 2 cosines. So I've got a cosine and a cosine. Secant is actually 1 over cosine, and again, squared means squared. That means there are 2 cosines on the bottom. So I've got cosine x, 1 over cosine x, cosine x. Notice I've got 2 on the top and 2 on the bottom. Those will reduce. And notice the only thing I have left over is a value of 1. So here I was able to reduce number 2 all the way down to a single value. So the answer to number 2 is just 1. All right, moving on to example 3. In example 3, I have cosecant minus cosecant times cosine squared. Something to point out, I noticed that the exact same trig value is in the beginning and in the second term, which means I can take out a cosecant. So we're going to take it out, almost like a reverse distributive property. So I've got cosecant in the front. If I take the cosecant out, I'm left with just a 1. Cosecant times 1 is cosecant. Minus, if I take out a cosecant, the only thing left is cosine squared x. Cosine squared x. So now our goal is to use one of the Pythagorean identities. Notice I'm looking for things that have squareds. The formula using cosine squared is the first one, but I got to move some stuff over. So let's do that. I'm going to take that original sine squared plus cosine squared is equal to 1. The goal is a 1 minus cosine. So if I subtract cosine squared from both sides, sine squared, we're going to use the x's, 1 minus cosine squared. So if I've got a 1 minus cosine squared, it's the same thing as replacing it with sine squared. So I'm going to cross out this large parentheses and just insert a sine squared. Again, it's being multiplied by this cosecant. Cosecant, feel free to use your notes, is the same thing as 1 over sine. Sine squared means there are 2 sines. These are on the top. Simplify sine. All I have left is 1 times sine x. This gives me sine x. Our goal was to simplify down to a single trig function, and I did. The last one on your notes page is number 4. Don't let the fractions scare you. We're going to handle this one piece at a time. So I am looking at the numerator first. I have a 1 and a cosine, so I'm going to be using formula 1. By manipulating that formula, I know that the top is going to turn into a sine squared. Now I'm going to look at the bottom. Secant squared minus 1. I'm going to be using that third formula. If I subtract 1 from both sides, that gives me secant squared minus 1, and it's going to be equal to a tangent squared. So I'm going to put tangent squared on the bottom. It will replace secant squared minus 1. Now I've got a sine squared and a tangent squared. This gives me a sine squared on the top, and I'm going to rewrite I'm going to rewrite tangent as sine and cosine. Tangent is sine over cosine. We cannot divide by a fraction. We multiply by the reciprocal. So let's take a look at what that looks like. Sine squared times the reciprocal. Cosine goes from the bottom to the top. Sine goes from the top to the bottom. Notice sine squared and sine squared will reduce. The only thing left will be cosine squared. So when I reduce this down to a single trig function, my single trig function is a cosine squared x, and this is my answer to number 4.